Augmented reality. What is it besides a keyword they slap on new products?
But if we were to put a name on this, we would call it extended reality, given by the acronym XR. So in this world of XR, there's VR, as previously mentioned, AR, and also MR. Some great examples of this is probably the very famous Oculus and HTC View. In the category of AR, probably familiar with it by Pokemon Go. So, Minecraft Earth. A brief explanation is MR, it's the goggles and all that. AR, it kind of has that funkiness, and you see it through your phone, right? And it kind of projects an image over your real world. Now, MR is similar in that sense, except normally, you only, on a graph, you have X and you have your Y. What MR does is it takes advantage of the Z coordinate, and now you have depth. Some examples of this are Microsoft HoloLens. Today, we decided that we're going to try to attempt to do this with our Project AIDS.
Thank you, Sean, for that amazing explanation. Now that we're a bit more familiar with extended reality, we can show off our crappy MR system that we have made, which is to the left over here. Here is a simple headset, a VR headset that you can buy at any dollar store. We cut it up, and we know that,
Okay, so we know that the design isn't exactly the best, but that's something that we want to fix in the future. I've worked on 3D modeling. You'll hear more about this later in the video. So
now, here we have a simple plexiglass screen with a privacy filter to block out some light so it can be more visible through. Now we have the plexiglass going at as close to a 45-degree angle as we can, so that when the light from the display over here goes down, it gets reflected back into the eyes of the user. Now here's a cool nifty diagram of the concept. This effect is called the Pepper's Ghost effect. It was first developed in, I think, probably the 1800s for live theater, and it allowed them to have like a ghost on stage. Now, what we're using here is a simple Raspberry Pi screen that I bought a while back. We're using it to be powered by a USB, and we have a simple HDMI cable leading to my laptop here. We decided to dim the lights for this demo because it's not exactly a bright display, but it does the job. And if I power up my code, I have a small USB, bear with me, USB cable. Now if I put this on, you can see possibly from that side that I am in fact looking at stuff through my screen. Now I'm running my Hololens code, and from here I'm able to look at different polyhedrons and different shapes that I have created within my code. Now, well, what we plan to do in the future is add an IMU, which is an inertial measurement unit. This device allows for gyroscopic and accelerometer data to be sent to my laptop, which we could program, so when we look around the room, we could look around the objects as well. To give you a perspective, see, all it does at the current moment is it shows three-dimensional polyhedrons and the time up on the really small font, but it's up there on the top left if you can see it. Oh wait, no, right in the center, my bad. Some of the problems I faced while programming was that I originally started in lightweight Java game library, and using that library I had a lot of trouble finding documentation on whether it be physics or just getting the rendering system to work. After scrapping that project, I moved on to using C++, using the free LUT API, and that has saved me time because it's more of a demoing library, which was neat. I plan to make a switch into a different library in the future, but that's for later to talk about.
Yeah, so now I'm going to talk about the build problems or challenges. So first off, I just want to say that this, even though it looks kind of sketchy and scrappy, this was worse at our first iteration of it, at least. Another thing that kind of threw us for a loop was, as simple as it may sound, the Pepper's Ghost effect. It was kind of difficult to implement because we couldn't find really thin acrylic glass. So the thinnest we found was, I think,
0.332.
Yeah, 0.332 of an inch. America.
Another problem that I faced with programming was I had to program in Z depth. So there's the X and Y coordinate, which on a 2D screen is easy to implement. But since I had to program this more like a game engine, I also had to program Z, so we can actually have three-dimensional objects in space.
So, I mean, this is more of a me challenge than exactly build challenge, but I just get used to Fusion 360, which if you can't get full-fledged Autodesk or AutoCAD, just like, please do yourself a favor, don't use Fusion 360. Unless you have to. I mean, it's better than like a lot of the options out there, but like, it was limiting in the options, and I had to get used to that. And I've made like 2 designs, but it took me way too long to do it, considering that. So that was one of the challenges. We ended up actually scrapping both those designs because, as you'll see later, we'll talk about future plans of using a Texas Instrument near eye display projector.
So future development. Sean, maybe tell us what you plan to do on the hardware side?
Yeah, so in the future, we want to come up with a design that's not really limited by its housing. So first we kind of thought, what if we kind of shrink down the screen so that way we could better utilize the 45-degree angle. But then we realized it would still be limited by the housing. We tried thinking about putting Velcro in, but then we would come up with the problem of double imaging, which basically means that it's too close to your eye and you kind of see a double image. Then we decided, what if we put a divider, and that would help fix the problem, also voice crack. But anyway, but we realized that probably wouldn't work either, so then we looked into the Hololens. The Hololens, they use diffractional grating, and that's pretty much like... So what diffractional grating is, let's say you had a light source. Now, everybody is quite familiar with the double slit experiment. It's when you have a wall, double slit, and when the wave and particles come through, most people would expect the interference pattern to look like 1 point here and 1 point here, whereas it actually didn't. It kind of spread out in ripples. So you had some dark spots and you had some light spots. Now what diffractional grating suggests is that if you have holes at the same exact point, the same exact distance, that is. So all of these X, what happens is that the lights tend to all kind of, so you gain all these points, and it increases the surface of the interference pattern. So at this exact point, you get a interference pattern that's greater in certain areas and lighter in less. This allows for more brightness and separation of colors. Of that. But it was way too complicated and way too expensive to actually implement the way Microsoft does it. So then we finally settled on using a Pico projector from Texas Instruments, and we're thinking about using that in the future. And displaying that at a 45-degree angle to still utilize the Pepper's Ghost effect. Another thing that we want to do is that we want to use a IR sensor on it, so that way we can get distance and have more control of that depth, and also put a dot matrix. Okay, what is a dot matrix? All right. So simply put, imagine a three-dimensional room. Let's say you have a man standing right in the center of this room. He's wearing a headset. What this projector allows us to do is create a sequence of dots. So little tiny dots, right? You could have a speckled pattern, the way Microsoft and both Apple do it, or the way we imagine doing it is a precise array sequence, which just simply stitches it together. And then you have a camera that analyzes these patterns so that you can better understand where it is.
Going more in depth of his explanation of the dot matrix, what we plan to do is make this system called what we call EMU, or Environment Measurement Unit. And what this does is it's going to, as he said, display a bunch of IR dots. Now, most cameras won't pick it up in a lighted room, so we're going to use an infrared camera to see where those dots are, and using some basic trig, we'll be able to calculate the distance of where those dots are hitting, and from there we could take those data points and send them over into my code, which will then make it into a mesh and render that so it could be an object. So say if I programmed the ball, it would be able to interact with the floor or a wall. And that would allow us to make a more lifelike extended reality device. Now, other future development ideas on the code side is I would like to add my IMU, which is an inertial measurement unit, as I said before. This, as I said before, would allow for the headset to know its gyroscopic movement, which would allow us to move in the world without using my laptop keyboard or mouse. Another device I would like to add is audio, whether that be input and or output. That would be nice to have, so we could do voice recognition and output of, say you want to listen to music or something. More on the code side, more in depth, is I would like to program Holos, make the code more neater, and develop a system, or not a system, a development kit for other programmers who aren't too familiar with Freeglut, to use my development kit to program new apps and other applications for my device. Also, that we want to make clicking functionality by using a IR camera to measure how far your hand is from the screen, and then from there we'll be able to interact with images on the screen just using your hand.
Yeah, going into what Isaac was saying about creating apps for this, well, one of the things that we talked about is that we kind of wanted to have a math functionality and also like an anatomy thing, so that way you could if it gets that far, that is, hopefully it does. Like you can take apart various different things and then like click on that object and it'll give you some information based on it, and that'd be really cool. Or you could have an interactive math calculator, so you could see graphs firsthand in one window, and it'll just increase productivity and also 3D models of this actual thing when it gets to that stage. So that would be really cool. And
I agree. The cool thing about virtual reality, or in this case mixed reality, is that no longer are we working on a 2D workspace like a laptop or desktop. We are literally opening up a new dimension of productivity and creation, innovation. And this allows us to make a new type of application or internet of things that we have never imagined before.
Yeah, I think that's all. Yeah, That's a wrap. Stay tuned on this because there's also other projects we're working on. A little sneak peek of something that I'm currently working on is I like to call it Project Monetary Justice. So I got $40 stolen from me, and
We'll see how he gets that back or finds the perpetrator.
yeah, that's basically it.
I also want to make some sugar rockets or sugar bombs. Go blow them off in that.
Yeah, we're also probably gonna do that.
Yeah, that would be nice.
All right.